morning friends. Welcome back to your favorite channel Code One Digest. Today in this video we will learn about Sidecar design pad for microservices. I'll explain what is Sidecar design pattern, where to use it, what are the advantages we get out of this pattern, and I'll give you the real world example of this design pattern. So stay tuned till end of this video. There is a lot of learning involved in this video. We will learn Sidecar design pattern with examples. Friends, in the previous video, we discussed about bulkhead design pattern. Can you explain what is bulkhead design pattern? Provide your answer in the comment section of this video. If you've not seen that video, I would recommend you to go and watch the previous video about bulkhead design pattern. The link is provided on your screen and also given in the description section of this video. So for more information, go and watch the previous video on Code One Digest channel. Friends, here is the agenda for this video. I'll give you introduction of sidecar design pattern. Then I'll show you real world example of sidecar design pattern. Then I'll explain the use cases of sidecar design pattern, where to use it in our project. Then I'll explain the benefits of sidecar design pattern. At the end, I'll summarize what we learned in this video. And then I'll give you very brief introduction of our next design pattern, that is API gateway design pattern. Okay, friend. So stay tuned till end of this video. There is a lot of learning in this video. You are going to learn a new design pattern today. Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share, and subscribe my channel so that I can grow Code One Digest family. Thank you.
So let's begin.
Okay, friends. So now let's start with the sidecar design pattern. Let's understand what is sidecar design pattern. And also remember, this is the sixth and the last design pattern in decomposition pattern category. So sidecar design pattern says deploy a component of an application into a separate process or a container to provide isolation and encapsulation. This pattern is named a sidecar because it resembles a sidecar attached to a motorcycle. In the pattern, the sidecar is attached to a parent application and provides supporting feature for that application. Sidecar pattern is what separating the cross-cutting operation to reduce its complexity of the services. For example, there are several modules that we want to run for each microservices like logging, messaging, monitoring, etc. This pattern can also enable application to be composed of heterogeneous components and technologies. The sidecar also share the same life cycle as the parent application and being created and retired along with the parent. As the sidecar is attached to a motorcycle, similarly in the software architecture, a sidecar is attached to a parent application and extends its functionalities. A sidecar is loosely coupled with the main application, hence we have flexibility to modify main application and sidecar application independently. The sidecar pattern is often used with the container and referred to as the sidecar container or a sidekick container. Okay friends, now let's understand sidecar design pattern with an example. Let's see a problem statement first. Application and service often require functionalities like monitoring, logging, configuration, and network services. And this peripheral task can be implemented as a separate component or services. If these peripheral tasks are also implemented and integrated with our main application, then they can make the application complex. It will create tight coupling, and with an outage of one of these components can affect the main application as well. So the solution to this problem is to co-locate a cohesive set of tasks with the primary application, but place them inside their own process or container, providing a homogeneous interface for platform services across the language. A sidecar service is not a necessarily part of application but is connected to it. It goes wherever the parent application goes. Sidecars are supporting processes or services that are deployed with the primary application. In microservice architecture, it is very common to see that multiple services require common functionalities like logging, configuration, monitoring, and networking services. This functionality can be implemented and run as a separate service within the same container or in a separate container, right? Okay, friends, now let's understand the sidecar design pattern with another example. Imagine that you have a six microservices talking with each other in order to determine the cost of a package. Each microservices need to have functionality like observability, monitoring, login, configuration, circuit breaker, and more. All these functionality are implemented inside each of these microservices using some industry standard third-party libraries. But is this not redundant? Does it not increase the overall complexity of your application? What happens if your application are written in a different language? How do you incorporate the third-party libraries which are generally specific to language? The service mesh layer you see in a diagram can live in a sidecar container that runs alongside your application. Multiple copies of same sidecar are attached along each of your applications. All the incoming and outgoing network traffic from an individual service flows through the sidecar proxy. As a result, the sidecar manages the traffic flow between microservices, gather telemetry data, enforce policies. In a sense, the service is not aware of the network and know only about the attached site proxy. This is really a sense of how the sidecar pattern works. It abstracts away the network dependency to a sidecar. Let's see another example of sidecar design pattern where we have legacy service missing HTTPS support. Hence, adding HTTPS to legacy service would be a complex and tedious work. And we don't have a code base of old applications and we don't want to disturb the working of old applications. Hence, consider a legacy web service which serves a request over unencrypted HTTP. We have a requirement to enhance the same legacy system to service requests with HTTPS in future. Okay, so the solution of this problem is the legacy application is configured to serve requests exclusively on the local host, which means that only services that share the local network with the server able to access the legacy application. In addition to the main container that is of legacy application, we are now adding a Nginx sidecar container which runs in the same network namespace as the main application so that it can access the service running on a local host. At the same time, Nginx terminates the HTTPS traffic on the external IP address of the pod and delegates that traffic to legacy application, right? Let's see another example of sidecar design pattern where we have to add a log aggregator to our application. Consider we have a web server which is generating access logs, error logs, and so on. These logs helps us in debugging the application for error scenarios. Hence, we need all these logs in a log aggregator tool. And we don't want to add complexity in the main application to send logs to log aggregator tool. So what do we do? So we introduce a sidecar application. As per separation of concern principle, we can implement the sidecar pattern by deploying a separate container to capture and transfer the access logs, error logs from web server to log aggregator. Web server performs its task well to serve client request and sidecar container handles access and error logs. Since containers are running on the same pods, we can use a shared volume to read and write the logs. Okay, friends, now let's understand what are the use cases of this pattern. Where to use this pattern in our project. So use this pattern whenever your primary application uses a heterogeneous set of framework or programming language. A component located in a sidecar service can be consumed by application written in different languages using different framework. Use this pattern when a component is owned by a remote team or a different organization. Uses pattern when a component or feature must be co-located on the same host as the application. Uses pattern when you need a service that shares the overall lifecycle of your main application but can be independently updated. Uses pattern when you need a fine-grained control over the resource limits for the particular resource or component. For example, you may want to restrict the amount of memory a specific component uses. You can deploy the component as a sidecar and manage the memory usage independently of the main application. When the services or components are implemented with multiple language or technologies, a service component must be co-located on a same container group. So friends, what advantage do we get using the sidecar design pattern? A sidecar is independent from its primary application in terms of runtime environment and programming language, so you don't need to develop one sidecar per language. The sidecar can access the same resources as the primary application. For example, a sidecar can monitor system resources used by both the sidecar and primary application. Because of its proximity to the primary application, there is no significant latency when communicating with the main application. Even for applications that don't provide an extensibility mechanism, you can use a sidecar to extend functionality by attaching it as its own process in the same host. This reduces the complexity in the microservices code by abstracting the common infrastructure related functionality to a different layer. This reduces code duplication in microservice architecture since you do not need to write configuration code inside each microservices. This provides loose coupling between the application code and underlying platform, right? Okay, friends, now let me summarize what we learned in this video today. I gave you introduction of sidecar design pattern. Then I explained you the real world example of sidecar design pattern. I gave you the use cases of sidecar design pattern. Where can you use it in your project? In which scenario sidecar design pattern helps you in solving the problem in microservice architecture? We also understood the benefits of sidecar design pattern. So friends, let me know if you have already used this design pattern in your project or seen a scenario where this design pattern is very useful. Please provide your answer in the comment section of this video. Friends, in the next video, we'll be discussing about API gateway design pattern. We will learn what is API gateway design pattern. We will see a real world example of API gateway design pattern. We'll understand the use cases of API gateway design pattern. We will see the benefits of API gateway design pattern. So stay tuned for the next video and keep watching Code One Digest. If you're new to the channel, so please do subscribe to our channel to grow Code One Digest family. Thank you. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.